Hey, it's Mr. O again, this time about acceleration. Last time we learned about distance and displacement, speed and velocity. So now let's recall velocity. Velocity is a vector. Velocity shows us in which direction an object is moving, which can be positive direction or negative direction, and that's just a matter of direction, so plus or minus. And now we're talking about acceleration. First, we want to understand that there are only three things that an object can be doing, and it can't do them at the same time, so it's only doing one out of those three things. Either an object is moving or not. If it's not moving, we say it is at rest. Then its velocity is zero. It's not moving, it's standing. If it is moving, it could be moving in two different ways. It could move at constant velocity. That means it's going at the same speed in the same direction. It's not turning any curves. It's not getting faster, it's not getting slower, so it's moving at constant velocity. Again, this can be positive or negative. Or an object, if it's not doing any of those things, then it accelerates. Acceleration means the change of velocity over time. So remember, velocity is a vector, and so is acceleration. If we change velocity, that can mean three different things. We can change the magnitude and the object can get faster, for example, or the object can slow down, or it can change direction because remember, velocity is a vector. If anything about this vector changes, including its direction, then you have a change of velocity and we call that acceleration. So getting faster is acceleration, getting slower is also acceleration, and changing direction when you otherwise drive at the same speed, it's also a type of acceleration. Acceleration, since it's a vector, can also be positive or negative. So again, here, something is at rest and then accelerates and gets faster, or something is already moving with some velocity and then accelerates, getting slower and coming to a stop. Here are the things that we would know about the situation. Vi is the initial velocity. In this case, when somebody's standing, of course, it's zero. And then final velocity, that is some velocity. If we started at zero, then of course we have some velocity. And this happens over some distance. We call it acceleration. And then, of course, it takes some time. So if this motorcycle starts from rest, and then accelerates until it reaches this place, or the end of this line here. It had initial velocity, here it has final velocity, and in between you have distance, acceleration, and time. How can we find the difference in velocity? Well, simply by subtracting the initial velocity from the final velocity. We also call that delta V, or the difference or change in velocity. Sometimes you have that change given, like the car changed by 5 meters per second. Sometimes you have the initial velocity given, sometimes the final. And at rest always means the velocity is zero, it's not moving. And then one special acceleration due to gravitational forces is in free fall, for example, is 9.8 meters per second square. Actually, because it's going in a downwards direction, would be negative 9.8 meters per second. Now, how to understand how velocity and acceleration work together. Let's say this motorcycle driver here is moving to the right, and let's let that be the positive direction. So then this driver has positive velocity. It's going to the right in the positive direction. If the acceleration is also going to the right, then the motorcycle will get faster because velocity and acceleration are going in the same direction. So they're helping each other. They work together. But if this motorcycle goes to the right and then has acceleration that's in the opposite direction, so going to the left, it will get slower because velocity and acceleration work against each other. Where does acceleration even come from? It comes from a force working on it. So, for example, if something moves into one direction, So here's an object, it's going to the right, then its velocity is the direction in which it is moving. If I now also push this box, okay, so I'm pushing this forward, there you go. I'm giving it a push, and that push causes acceleration, and that acceleration is in the same direction. Now the box is going to move faster. If this box is moving in this direction, and then suddenly I start pulling in the opposite direction, so I'll say here's a string on the box, and I'm pulling it in this direction, then I give it acceleration to the left, that would be the negative direction, and the box will get slower. So does that mean negative acceleration always means going slower? Absolutely not. Just knowing the acceleration and its direction does not tell us in which direction the object is moving and whether it's slower or faster. What we need to know is where it actually, what the velocity actually is. So when we know the velocity and we know the acceleration, then we can determine if something gets faster or slower. So an object moving in the negative direction, that would give it negative velocity, also having negative acceleration. So the push is also in the same direction. That makes it faster in the negative direction. And if something is moving in the negative direction, but experiences a push or pull in the positive direction, so here's where the object is going, negative velocity goes in the negative direction. But now something is pulling on it and giving it positive acceleration. That makes it slower because velocity and acceleration work against each other. And that's pretty much the most important point about this, that you have to look at which way both of them are going. Okay, positive velocity is velocity in a positive direction. Negative velocity is velocity in the negative direction. Same is true for acceleration. Positive acceleration is acceleration in the positive direction. That doesn't mean it goes there. It just means there's a push in that direction that causes the acceleration. And negative acceleration is acceleration in the negative direction. That also doesn't mean it gets slower. Depends on where the velocity goes. See you next time with the motion graphs. Thanks for listening.